Looking back at the reference image, we can see that the transformer uses two types of cooling fins, one with a length of 200 millimeters and another with 250 millimeters. In the project browser, under generic models, duplicate the existing nested fin family and rename them to L200 and L250 respectively. For the L250 family, assign new parameters in the same way we did for the L200 in the previous episode. After assigning these parameters, update the length of the L250 fin to 250 millimeters. Now let's begin arraying the 200 millimeter fins on one side of the transformer. Select the fin, then click on the Array tool. Here, there are a few important options to understand. Since the fins in this transformer are arranged in both vertical and horizontal directions, we'll use linear mode. Next, you'll need to choose between move to second or move to last. These modes determine how Revit calculates spacing, either the distance between the first and second component or between the first and last one. Choose the mode that best suits your project. Let's go through two quick examples. In the first example, choose move to second. After selecting the start and end points, a dialog box will appear asking for the number of fins. In this mode, no matter how many fins you array, the spacing between each fin remains constant. In the second example, select Move to Last, then enter the same start and end points and input the desired number of fins. In this case, Revit adjusts the spacing automatically so that all the fins fit within the given span. Be careful not to array too many components too closely, or you may receive an error message stating that the command cannot be completed. Another important option is Group and Associate. When this is enabled, all fins in the array are grouped together. If you enter the group environment and adjust one component, the changes will apply to all. Disabling this option means you'll have to set the number of components manually during array creation, and the fins will not be linked as a group afterward. Finally, the constraint setting ensures your array remains aligned either vertically or horizontally. This prevents unintended placement along diagonal directions. Now let's apply this to the model. Select the 200 millimeter fin, click on the Array tool, define a start and end point, and choose a random number of components. You can adjust this later. Based on the reference image, the first fin is spaced 250 millimeters from the side of the transformer body. To match this, create two new reference planes offset 250 millimeters from each side of the transformer. Use the Align tool to snap the first and last fins to these reference planes and lock them in place. Then, activate multiple alignment to align all the intermediate fins to the face of the transformer body. Switch to the left view to check vertical placement. Align the fins so they sit at the same height above the ground as the steel panel. Repeat the same process to the L250 fin. Complete installing all the fins on each side, and we can move on to the next chapter.
Looking for piping catalogs you can trust? At pipingcontent.com, you'll find ready-to-use libraries for AutoCAD Plant 3D, Revit, Smart 3D, E3D, and more. Get instant access to valves, fittings, and components. Click on the link below in description section and explore pipingcontent.com today.